Let's discuss this question. Express the following matrices as the sum of a symmetric and skew symmetric matrix. Okay. How are we supposed to do that? Okay. So, expressing any matrix as a sum of symmetric and skew symmetric matrix, we have a standard process. What does that standard process say? So let A is any matrix, right? For any matrix A is any square matrix. Okay. A can be written as the sum of this and this, right? This matrix here is a symmetric matrix, okay? Half times symmetric would be a symmetric. This matrix here is a skew symmetric matrix, half times this would be a skew symmetric matrix, and if you add them together, what you will get is A. I don't want to add them together. What I'm saying is the converse of that. I'm splitting A as sum of these two, and where this is a symmetric matrix and this here is a skew symmetric matrix. This here is a skew symmetric matrix. I'm writing it as sum of this and this together. Can you please observe that? Yes. Pretty simple? Yeah, pretty simple for that matter. Express the following matrices as sum of symmetric and a skew symmetric matrix. That's what we have. Right. Keeping this in mind, can we continue further and express this matrix as sum of symmetric and skew symmetric matrix? Yeah, we can do that. Let's begin with assuming this matrix as A. So, this is the first part. Let A equals 3, 5, 1, minus 1. Once I have this, can I find A prime first? Yes, implies A transpose, that is A prime, which is equal to 3, 5, 1, minus 1. Okay, this is 1 and this is 2, let's say. Using 1 and 2, I'll have to find A plus A prime and multiply it with half. We'll also have to find A minus A prime multiplied with half as well. Okay, so therefore, A plus A prime is equal to what? Half of A plus A prime is equal to what? Or we can say, let P is a matrix which is half of A plus A prime. What is that? Half of the sum of these two matrices. What is that? 3 plus 3 is 6, 5 plus 1 is 6, 1 plus 5 is 6, and minus 1 minus 1, the sum is 2, minus 2, sorry. On multiplying it with half, this gives me P equals 3, 3, 3, minus 1. Okay. This is the matrix P. This is the matrix P. Observe that P prime is equal to 3, 3, 3, minus 1, which is equal to P only, and implies P is a symmetric matrix. Pretty interesting. We have found P and P is a symmetric matrix. What next? I know that I have to find another kind of matrix based on this A. What is that? Half of A minus A prime. Okay. Now let Q equals half of A minus A prime. What is that? Half of the difference of these two matrices, A and A transpose. 3 minus 3 becomes 0. 5 minus 1 becomes 4. 1 minus 5 becomes minus 4. And minus 1 minus of minus 1, that is minus 1 plus 1 becomes 0. Multiplied with half, that gives me Q equals 0, 2, minus 2, 0. Okay. And observe this matrix Q very carefully. Q transpose is equal to 0, 2, minus 2, 0. Okay. Let's take out a minus common. Oh, what do you mean by taking out a minus common? I am taking out a factor of minus 1 from each element. This is minus 1 times 0, 2, minus 2, 0. And this here is nothing but Q. This is minus of Q. Q prime is equal to minus Q. If Q prime is equal to minus Q, implies Q is a skew symmetric matrix. Q here is a skew symmetric matrix. Yeah, Q is a skew symmetric matrix. Once we have found that Q is a skew symmetric matrix, let's check what is the sum of P and Q. Let's check the sum of P and Q. Now, P plus Q is equal to what? P is this 3, 3, 3, minus 1 plus Q is 0, 2, minus 2, 0. The sum, as you may observe, is 3 plus 0 is 3, 3 plus 2 is 5, 3 plus minus 2, 3 minus 2 is 1, minus 1 plus 0 is minus 1, and this is 3, 5, 1, minus 1, which is the original matrix that we started with. This is equal to A. Basically, A has been written as a sum of two matrices P and Q, where P is a symmetric matrix, Q is a skew symmetric matrix, using this idea and this idea over here. So the matrix A has been written as a sum of this and this matrix, right, where P is symmetric and Q is skew symmetric matrix. Is that all? That is all for this part over here. Let's move on to the next part for this question. The second part, what does the second part say? Once again, we have to write this matrix as a sum of symmetric and skew symmetric matrix. Now, since we have understood the process of writing it as a symmetric and skew symmetric matrix, what I'll directly find is half of A plus A prime and half of A minus A prime. Let's say, let A equals this matrix 6, minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. This is what I have. Implies A prime would be equal to what? A transpose. That is 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. Okay, and using these two, let P equals half of A plus A prime and Q equals half of A minus A prime. These are symmetric and skew symmetric matrix. This is symmetric and this is skew symmetric matrix. P and Q are symmetric and skew symmetric matrices. Therefore, P equals half of sum of these two. What do you get? 6 plus 6 is 12. Okay. Minus 2, the sum is minus 4. 2 and 2, the sum is 4. Okay. Minus 2 and minus 2 over here is minus 4. My 3 and 3 over here is 6. Minus 1, the sum is minus 2. Okay. 2 and 2, the sum is 4. Minus 1, the sum is minus 2. 3 and 3, the sum is 6 over here. Pretty interesting. Why? Because, okay, this original question is a symmetric matrix in itself. Very interesting. Next, P is equal to half of this. This becomes equal to what? This becomes equal to 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. This is what I have. This is the symmetric matrix that you obtained, because this was the original question also is a symmetric matrix. So this is the symmetric matrix, same as A. What about Q? If you find Q over here, Q would come out to be a null matrix. And Q equals half of A minus A. What is that? 6 minus 6 is 0, minus 2 gets, everything gets cancelled. Can you observe that everything gets cancelled? This becomes a 0, 0, 0, 0, 0, 0, 0, 0, 0. That's a null matrix, and which is equal to this matrix over here. Therefore, since, can you observe that P plus Q is equal to P plus Q, matrix P plus Q is equal to 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3, which is the matrix A. Hence, have we expressed the matrix A as a sum of symmetric and skew symmetric matrix? Yes, this is sum of symmetric and skew symmetric matrix over here. This is our matrix A, as you can observe clearly. Now, this is part 2. What about part 3? Can we continue and move on to part 3? Yes, this is part 3 over here. Now, observe this part 3. Let's assume it as a matrix A, and next we'll solve using the concepts developed that symmetric matrix and skew symmetric matrix would be half of A plus A prime and half of A minus A prime. Okay. So let A equals this matrix 3 minus 2 minus 4, 3 minus 2 minus 5, minus 1, 1, 2, and A transpose would be equal to what? This is 3, 3, minus 1, minus 2, 1, minus 4, minus 5, 2. This is what I have. Let A equals this matrix and A transpose equals this matrix. Okay. Let P equals half of A plus A transpose and Q equals half of A minus A transpose this will be symmetric and this will be the skew symmetric matrix that we require. Right. Therefore, P is half of the sum of these two matrices. Let's find the sum of these two matrices. 3 plus 3 is 6. This is 6. 3 minus 2 is 1. Minus 1 minus 4, the sum is minus 5. That's what we have. What next? Minus 2 plus 3 is 1. Minus 2 minus 2, the sum is minus 4. And 1 minus 5 is minus 4. Next, minus 4 minus 1 is minus 5. Minus 5 plus 1 is minus 4. 2 plus 2 is 4. This is the matrix P, which is equal to further 3, 1 by 2, minus 5 by 2, 1 by 2, minus 2, minus 2, minus 5 by 2, minus 2, 2. This is what I have, right? This is matrix P, which, as you can clearly observe, is a symmetric matrix, right? These two elements are same, right, across the diagonal elements, right? What next? And Q matrix is half of A minus A prime. What is that? Difference of the two. So let's take the difference by subtracting the corresponding elements. 3 minus 3 is 0. 3 minus of minus 2 is 5. Minus 1 minus of minus 4, that is minus 1 plus 4, which is 3. Minus 2 minus of 3 is minus 5. Minus 2 minus of minus 2 is 0. 1 minus of minus 5 is 6. Next, minus 4 plus 1 is minus 3. Minus 5 minus 1 is minus 6. And 2 minus 2 is simply 0. This is what I have. This is Q, which is further equal to what? This is further equal to, let's multiply with half, and what you get is 0, 5 by 2, 3 by 2. This is minus 5 by 2, this is 0, this is 3, this is minus 3 by 2, minus 3 and 0. This is what I obtain. And can you observe that matrix Q is a skew symmetric matrix? Yes. Diagonal elements, the other than diagonal elements are negatives of each other. Observe that P plus Q is equal to what? The sum of these two matrices, P and Q. 3 plus 0 is 3. 1 by 2 plus 5 by 2 is 6 by 2, which is 3. Yes. Minus 5 by 2 plus 3 by 2 is minus 2 by 2, which is minus 1. Okay. 1 by 2 minus 5 by 2 is minus 4 by 2, which is minus 2. Minus 2 plus 0 is minus 2. Minus 2 plus 3 is 1. What about the third row? Minus 5 by 2 minus 3 by 2 is minus 8 by 2, which is minus 4. Minus 2 minus 3 is minus 5. 2 plus 0 is 2. And what is this matrix equal to? P is a symmetric matrix. Q is a skew symmetric matrix. The sum of these two matrices is equal to, is it equal to this A? 3, 3 minus 1 minus 2 minus 1. Yeah. This is equal to this matrix A. And hence we have written A as sum of two matrices. One of these is symmetric, the other is skew symmetric. These are the given matrices. That's this part for us. What next? Let's move on to the next part. What is the next part? This part over here. Following matrix is sum of symmetric and skew symmetric matrix. Okay. Let's express this also. This simple 2 by 2 matrix, which should be very easy to crack. Yes. This is matrix A. Okay. 1, 5, minus 1, 2. Implies A transpose would be equal to 1, 5, minus 1, 2. Okay. Can I find the matrix P equal to half A plus A prime, which is equal to half the sum of these two matrices? What is that? 1 plus 1? 2. The second element 5 minus 1 would be 4. Minus 1 plus 5 would be 4. 2 plus 2 would be 4. And let's divide by 2. This is 1, 2, 2, 2. Is it a symmetric matrix? Yes, this is a symmetric matrix. Observe, this is a symmetric matrix. And Q is equal to half of A minus A transpose. What is that? Half of, let's take the difference. The first element 1 minus 1 will be 0. The second element 5 minus or minus 1 would be 6. Third element minus 1 minus 5 would be minus 6. And 2 minus 2 would be 0. Over here, what does that become? This is 0, 3, minus 3, 0. Can you observe that this is a skew symmetric matrix? Can you observe that this is a skew symmetric matrix, right? And the sum of these two matrices, P plus Q, if I find P plus Q, what is that equal to? 1 plus 0 is 1, 2 plus 3 is 5, 2 minus 3 is minus 1, and 2 plus 0 is 2. And is this equal to this given matrix? Yeah. So the matrix A has been written as sum of two matrices, one of which is a symmetric matrix, the other is a skew symmetric matrix, as you can clearly observe over here. That is all for this question, as you can clearly see, right?